Limit as x goes to 0 of tangent of 3x times sine of 4x divided by 2x cosine of 6x. The first thing we're going to do is try plugging a 0 in for each of the x's. That will give us a tangent of 3 times 0 times the sine of 4 times 0 divided by 2 times 0 times the cosine of 6 times 0. Any number times 0 is 0, so we would end up with tan of 0 sine of 0 divided by 0 times the cosine of 0. The tangent of 0 is sine of 0, which is a 0, over cosine of 0, which is a 1. 0 over 1 is a 0. Sine of 0 is a 0. And then over 0 times the cosine of 0, which is a 1. 0 times 0 is 0. 0 times 1 is 0. We have the 0 over 0 indeterminate form. Since this is resulting from trig functions of different phases and power functions, we're going to make use of the identity. Limit as theta goes to 0 of the sine of theta divided by theta is equal to 1. In order to make use of this identity, we need to change the tangent of 3x into sine of 3x over cosine of 3x. We also have a sine of 4x, and then all of this divided by 2x cosine of 6x. Since we have a fraction in the numerator, we need to take the denominator fraction, reciprocate it, and multiply it. It's not a fraction right now, but we can make it a fraction by putting it over a 1, so let's do that. And now we will reciprocate that denominator fraction and multiply with the numerator, which is sine of 3x over cosine of 3x times sine of 4x, and then times the reciprocal, which is 1 over 2x cosine of 6x. The middle term we can make a fraction by putting it over a 1, just so we can easily see how to multiply these fractions. We multiply all the numerators. Sine of 3x times a sine of 4x times a 1 divided by cosine 3x times a 1 times a 2x, I'll put that first, and times a cosine of 6x. We still have the 0 over 0 indeterminate form. That hasn't changed just yet. What we need to do is isolate the sine functions. There's two of them. They're both in the numerator. We're going to isolate them into their own fractions. So we'll have a sine of 3x in the numerator, a sine of 4x in the numerator, and then all other terms in their own fraction. They're all in the denominator, 2x cosine 3x and cosine of 6x. Now what we need to do with the signs is match their phase in the other position. We have a sine phase of 3x in the numerator. We need a 3x in the denominator, and then we will compensate this by putting a 3x in the numerator of the other fraction. And then we have a sine of phase 4x in the numerator. We need a 4x in the denominator. Again, compensate by putting a 4x in the numerator of the other fraction. The other fraction we can cancel one of the x's. They're multiplying each other, so really it's an x squared up there. One of the x's can cancel, not both of them. And then we can actually cancel the 4 and the 2 with each other to become a 2 and a 1. The next step, let's just rewrite what we have left here. We have sine of 3x divided by 3x. We have a sine of 4x divided by 4x. Both of those are in perfect form to be the identity. And then we have a 3x times 2, which is a 6x divided by a 1 times cosine 3x and a cosine 6x. The first fraction is the perfect identity, matching the phase of the sign with the other position. The second fraction, same thing, the identity. Both of those are going to be 1s. And this will eliminate the 0 over 0 indeterminate form. So we have 1 times 1 times, and now we can plug a 0 in for the remaining x's, so times 6 times 0 divided by the cosine of 3 times 0 and the cosine of 6 times 0. 1 times anything is that same thing, so we just have the fraction left over. 6 times 0 is a 0 over cosine of 3 times 0 is a 0, and 6 times 0 is 0. So we have 0 over cos of 0, which is a 1, times another cosine of 0, which is a 1. 0 over 1 times 1 is 0 over 1. 0 over any non-zero number is equal to 0, and there's the result of that limit.